really HFE, as the science that deals with human health and well-being, has a key role to play in responding to these challenges. And really, there's two kind of aspects to that. The first really is that a key feature of most of these massive global risks is they're often highly complex, of course, but they're human-centered. So they're brought about by human behavior in the first place, and also effective management of them really does require widespread changes in human, organizational, societal behaviors. We do have a set of theory and methods that really are capable of helping to understand some of these issues. And I'm talking particularly here about systems HFE. And so we feel strongly, and also Andrew does as well, that systems HFE is really suited to analysing and responding to these global risks. Why do we say that? Largely because these methods are designed to actually describe overall complex problems and complex systems. And I guess the key point is that they look at the interaction between different parts of a system and what emergent behaviour arises from that. And I think that has an important role to play in kind of responding to some of these issues. And so most of you will know work domain analysis. For those of you who don't, it's basically a systems analysis method from the cognitive work analysis framework. What you're doing really, you're producing an abstraction hierarchy which describes the purposes of a system, the values within the system, basically the things that need to be done to achieve the purposes, and then all of the objects that are used for this. And you also, through means, ends, links, then look at how all of these things relate to one another. And it's actor independent, so you're just really modeling the system rather than the people within it. And so we basically think that this is one of those useful methods that can really design these, describe and help understand these highly complex global risks. And so the first kind of test we did of this was we really wanted to test the idea that systems HFE methods can deal with large-scale, highly complex modeling problems such as these global risks. And we basically set about developing a work domain analysis of the world. And, what we wanted to do here is really test the assertion that WDA could cope with problems at a global scale. And you can see we were able to develop quite a usable and actually decipherable model of the world. And there was some interesting things that we then did with that. We started to then look within the model to see whether there were leverage points, whether there were any leverage points or places in a system where you can intervene to have large and dramatic effects. What we're kind of coming to is, we've talked a bit about method selection tonight. Really, when you're faced with these large-scale complex problems, we actually think a many model approach is the best way to do. So instead of trying to work out, well, should I use STAMP or should I use the hammer, as we've heard it called tonight, work domain analysis, or causal loop diagrams, actually our work looking at road trauma kind of suggests that you should use all of them. And Scott Page is a complexity scientist who kind of talks about, when you've got these large-scale, hugely complex problems, you don't need to pick a method, you throw the lot at it. And we've actually tried that with systems HFE, and it works very well.